Welcome to a brand new science topic. You're going to be learning some very interesting stuff. So we're going to get started because this is going to be quite a long video. So we're going to be learning today all about objects in motion. And motion is that important word that we're going to be concentrating on. So, in this lesson, you're going to be learning the basics of motion, which some of you may know a little bit about already. You're going to learn about the types of motion and that motion is relative. I'll explain more about what that means later in this lesson. Also, you're going to understand what velocity and speed is, okay? And finally, your task is you're going to be creating a short presentation explaining all about the things you've learned. So let's get started. Okay, so we're going to be talking about three main key questions in this lesson. The first one being, what is motion? What types of motion are there? And also, what does relative motion mean? Okay, so those are the three key questions you should have right now that we're going to answer. So let's start with the basics. What is motion? Now I'm going to ask you a question at the beginning of this slide and at the end of this slide. What objects around you are in motion right now? So have a look around you. Is there anything in motion right now? Okay, I'll ask that question again in a minute. So motion in physics is the phenomenon which an object changes its position over time. So any object that changes position over any course of time is motion. Motion is mathematically described in these terms: relativity, distance, velocity, acceleration, speed, and time. So that is motion. So basically, when things move, okay, like me in this car, all right, we're talking about motion. All right, let's carry on. No. What objects around you are in motion right now? So that same question again. What is in motion right now? Let's talk about the types of motion now. Okay, so we've got four images down below, and these four images are going to show all the types of motion, because you probably think there are many different types of motion, but actually there are only four. Now, those four motions can have different characteristics, but really there are four main types. So the first one is linear motion. So when an object moves in a straight line, it doesn't have to be a straight line, it could be a curved line or a wiggly line, but if it moves forwards or backwards or up or down or diagonally, if it's moving in a line, then it is linear motion, just like this train. Okay, so this train going along a track would be in linear motion, just like a car going down a road. Okay, the second one is circular motion. So when an object moves around or along a circular path, just like this Ferris wheel, okay, so all of these here, that, gentlemen, is a circular motion. All right. The third one is rotational. So when an object moves around an axis, it is rotating, and that is rotational movement. Just like you guys learned earlier this year all about the Earth. The Earth spins on an axis, so the Earth has a rotational movement or motion. And finally, we have oscillatory. Okay, this one's a bit more complicated, but basically it's when an object moves in a repetitive way, just like the pendulum on a clock. Okay, so if you see a pendulum moving backwards and forwards, it is oscillatory. Okay, now oscillatory motion is very common in car engines. So if you know anything about how a car engine works, then that's a lot of oscillatory motions. Okay, so they are the four types. So just a bit of practice then, and a bit of extra info. One object can actually move in many different ways. So just one object can have many different motions. This Ferris wheel, for example, okay, it has obviously rotational motion, okay, because it's going around an axis, okay, but it also has circulatory motion because the cars are going around in a circular path, okay, but in the center it's obviously rotational. What about this helicopter then? Yeah, so a helicopter, okay, we know that the blades above are obviously going around in a rotary fashion, but the helicopter moves forwards as well, so it has a linear motion, okay. And what about a laptop? Now, just the outside of laptop has, okay, a bit of a pendulum, a hinge, yeah. Okay, so it's a the fourth motion, okay, which is oscillatory. But also inside there are lots of moving parts. So a laptop is doing lots of different motions. Okay, now quick challenge. Okay, you can do right now. How many ways can you move your right arm? So right now you can do it yourself. How many different motions can your right arm have? Just your right arm. Okay, and I can imagine it's quite probably all four. Yeah, so have a go at that. You can pause the video if you want. Okay, moving on, and this is a bit more complicated, so please bear with me. All right, we're going to use this train. This is very important to what we're going to be talking about now, and we're going to be talking about relative motion. Okay, so think about it this way: the house that you're sitting in right now isn't moving, right? Okay, that would be terrifying if your house suddenly started moving. Okay, houses are made to stay still or motionless. Okay, but that's because we're basing the movement of a house on everything else around it. Okay, so as you move around your house, you're in motion, but your house is not. Okay, now this is why motion is relative. All motion is relative, and to understand what this actually means, we're first going to need to explain something called frame of reference. Okay, so this train is going to move. In fact, it's moving right now. And how do we know it's moving? Okay, because it looks stationary, right? Okay, well, what if we put a tree just here? And then we're going to move the train. Okay, so let's get the train fired up. Okay, and off it goes. So we can see that the train is moving. Okay, but what about the tree? Is the tree moving? No, the train moves, but the tree does not. Okay, so this is because the tree is not moving and it's relative to the train. Okay, so it's not moving relative to the train. The train is moving and the tree is not. So we can use our tree as a frame of reference. A frame of reference is something that doesn't move, okay, and we can base something that does move off that reference. Okay, so let me think of another one. The road that you drive a car on doesn't move, but the car does move. So the car and the road are relative. Okay, so we know the car is moving because the road is not. So that, gentlemen, is frame of reference, and that's how we show that motion is relative to a frame of reference or something that's not moving. Okay, however, it gets a bit more complicated. Okay, now these two trains here are moving. I want you to imagine they're moving along a track right now. Okay, but they're moving at the same speed right next to each other. So they're moving at let's say 50 kilometers an hour, both of them. Okay, now we don't have any frame of reference here, so as they're moving we can't see that they're moving, can we? Okay, now this is because the trains are in motion, but they are only relative to each other. Okay, so there's no other frame of reference. The only frame of reference this train has is the train next to it. Okay, so if you use the other train as a frame of reference, they appear to not be moving or not in motion. Let me explain that in a way that you know. Imagine you get in your car and you go and drive, or your parents drive you to a ranch or on vacation somewhere. Okay, now imagine a car next to you is moving along at the same speed. You can look over at that car and you can see the person inside the car. okay, and they don't seem to be moving anywhere because you're traveling at the same speed. So if you reference something that's traveling at the same speed as you, okay, it appears that you are not in motion. This is why frame of reference is extremely important. Now, final explanation of this, I'm going to blow your minds. Now, is this tree moving? Is it in motion? Or is any tree in motion? Is your house in motion? Okay, now the answer to that would normally be, well, no. Okay, your house isn't moving and this tree isn't moving. But what about if we use the earth as a frame of reference? Is the earth moving? Yes, it is. It's moving in a rotary fashion around an axis. Okay. Now, if we use space or the sun as a frame of reference, what is your answer now? Okay, we in fact are all moving. All the houses and trees, everything on the earth is moving. Okay, but we have to see a bigger frame of reference to understand that we are all moving. So there are many different motions all going on at the same time and all relative to a frame of reference. That's very complicated. Okay, if you need to go back and watch this part again, please, I invite you to do so. All right, I will also answer questions in our video session. Okay, so that is relativity and frame of reference. Okay, final part, how to measure motion. Okay, we're going to go through this very quickly. We can measure motion in many mathematical ways. However, the most common are speed and velocity. Now, some people mix these up and they think they're the same thing, but actually they're a little bit different, okay? First of all, speed measures the rate at which an object changes position, okay? So if an object is in one place and it moves somewhere else, okay, we measure it with speed, okay? Now, we need three things to calculate speed. The first one, we need a unit of distance, okay? So we can say a meter or a kilometer or anything you want, okay? Now, we also need a unit of time. We need to measure how long it takes to move, okay? And obviously, the third one is we need a moving object, all right? Now, you've all seen in your cars, you have a speedometer, okay? Now, this speedometer measures speed, okay? Very simple, all right? And we can measure speed with a very simple formula, which is speed equals distance divided by time. And that's why when we talk about speed, we have the number and kph, which is kilometers per hour. So if you're doing this, every hour you're traveling 100 kilometers. Okay, so that is speed. Now, how is velocity different? Well, velocity measures speed and takes into consideration the direction of the object. All right. Now, the direction could be a corner in a road or a plane taking off. Okay, so it could be going up or down. And velocity shows that the speed changes depending on the direction. And if you don't want the speed to change, you have to put more force into the object moving. But that's all for another lesson. Okay. So I want you to imagine a plane taking off. Now, when a plane goes into the sky, it needs to put its thrusters, its engines on really powerfully so it can get up into the sky. Yeah? And that's a velocity. All right, so going upwards into the sky and forwards is the velocity. Now, when a plane comes into land, it doesn't need any engine power whatsoever. It glides down, it uses gravity to come back down, but at the same speed. Okay, so that is what velocity is pretty much all about. Any problems? Send me some questions. Otherwise, we'll speak in our video chat. Okay, and feel free to watch this video again and again and again. All right, thanks, guys.